Let's look at question 41 to 50 of the 2021 JAMB Physics examination questions. 41 here says a cell of internal resistance small r supplies current to a 6.0 ohm resistor and its efficiency is 75%. Find the value of R. Okay. A 8.0 ohms, B 4.5 ohms, C 2 ohms, D 1 ohm. So how do we solve this question? Now for this question, let's take parameters. So 41. So 41. They gave me efficiency E as equal to 75, of course, in percentage. They said a cell of internal resistance, small r. So internal resistance, which we are asked to find, small r is equal to unknown. They said supplies current to a 6.0 ohm resistor. Now, this 6.0 ohm resistor is the external resistance. So external resistance R, capital R, is equal to 6 ohm or 6.0 ohm. Basically, you're asked to find the value of small r. And how do you solve that? You want to record that E is equal to capital R, that's external resistance, all over the sum of external and internal resistance. So this is what you have. Now let's solve for this. The value of E is 75%. And of course, this is all over 1. If I cross multiply E times this, you have E times external resistance plus internal resistance is equal to capital R times 1, which is capital R, that's external resistance. We have to find the value of small r. And what do you do here? Divide here by E, divide here by E. From here, this cancels this. So R plus R is equal to R all over E. To get the value of R, I'll move small r, I'll move capital R here. That means small r, internal resistance, is equal to external resistance, capital R, all over efficiency, minus, right, this is positive, moves over the equality sign, becomes negative R. Let's impute values. This is equal to capital R, the value is 6, so 6 all over. Now the value of E here, don't forget we said is 75%. We'll convert this. 75% is simply 75 all over 100, and that's equal to 0.75. So E is actually 0.75, which is 75%. So all over 0.75, 75% minus R. The value of R again is 6. That's external resistance. And this would be equal to, so let's punch 6 divided by 0.75. That's about 8. So 8 minus this 6 here, and that's equal to 2. Resistance is in ohms. So that means the internal resistance, small r, is equal to 2 ohms. So R is 2 ohms. So which option is that? Let's see. That is C. The correct answer here is C, 2.0 ohms. Question 42. If a ball is released from a height of 20 meters, how long will it take to reach the ground? Assuming G is equal to 10. A, 2 seconds. B, 3 seconds. C, 3.5. It should be 6. So I'll put seconds. Right? So seconds. And then D, you have 2.4 seconds. So how do we solve this particular question? Now, let's list our parameters. They said the height here is 20 meters. So for 42. So 42, the first we're given there is height, H, as equal to, they said the H there is 20 meters. That's 20 meters. Take acceleration to gravity as 10 meters per second squared. You're asked to find what exactly they said. How long would it take? So how long, talking about time. So T is equal to unknown. Now, this question is under free fall, all right? We've also discussed the concept of free fall. Check the JAMB and post-UTME classes, all right? Go to playlists, check the JAMB and post-UTME classes under motion. We've discussed this particular topic. And for this question here, we use the equation of motion. Now recall that one of the equations of motion says that S is equal to ut plus half at squared. We're using the same equation here, but in the concept of free fall. It is free fall because if you look at the question, they said a ball is released from height. So basically, this ball, let's say you have a ball here being released from height, it is falling vertically downwards. And when a ball is moving vertically downwards or vertically upwards, we'll use the free fall concept. And in free fall, S is equal to H. So have that H is equal to UT plus half. Then you have A, all right? A becomes G in free fall. So I'll replace A by G and T squared. Now you want to know that since the body is being released from a height, that means the body is falling downwards. And when it's falling downwards, this becomes plus. Since the body is falling downwards, the sign here becomes positive. All right. Then again, looking at the question, they said a ball is released from a height. When they say a ball is released from a height, it means the ball was stationary and then it was released. In essence, the initial velocity u will be equal to 0. If u here is 0, it becomes 0 times t, and this gives you 0. So you have that h is equal to half into g. The value of g is 10, and then t squared. What's the value of h again? That value is 20. So you have that 20. It's equal to half of 10 is 5. So 5 t squared. Divide here by 5. Divide here by 5. This cancels this. You have that t squared is equal to 20 over 5. That gives you 4. To get t becomes the square root of 4. Take square root, and that gives you 2. Time is in seconds. So t becomes 2 seconds. So in essence, for this question, the correct answer there is for 42 is 2 seconds. That's option A, 2 seconds. Next up, 43. 43 says an object O lies at a distance m in front of a concave mirror of focal length f. If m, right, that's the distance, is lesser than the focal length, then the final image obtained will be A, virtual and diminished, B, magnified and erect, C, real and inverted, D, diminished and erect. Now you want to note that if the object distance m is less than f, what will happen is simple. For this case, the final image obtained will be number 1, it will be virtual. Number 2, it will be erect. Number 3, it will be magnified. So you have this. It will be virtual, it will be erect, it will be magnified. So which of these options matches all of this? This one says virtual and diminished. No. This one says magnified and erect. Yes. B works. C says real and inverted. No. This says diminished and erect. So the correct answer would be B, magnified and erect. It matches magnified, it matches erect. But to take note that it can also be virtual too. All right. But let's take B. That's magnified and erect. That's the correct answer. Okay. Next up, question 44. It says a body dropped from rest to reach the ground in about 0.15 seconds. Calculate the height from which it is dropped. Take g as 10 meters per second squared. A 0.25 meters, B 3.5 meters, C 1.35 meters, D 0.11 meters. So how do we answer this question? Again, we use the same concept as we used initially. Now, in solving this, I said a body is dropped from height, dropped from rest to reach the ground in about 0.15 seconds. So 44, you give us the time there, t as equal to 0.15 in seconds. You're also giving g, or you're told to take g as equal to 10 meters per second squared. What else? They said you should calculate the height from which it is dropped. So h, height from which it is dropped, h is equal to unknown, right? So how do we solve this question? Again, we'll still use this same equation. Recall that h is equal to ut plus half gt squared. Now they said a body dropped from rest. And when a body starts from rest, its initial velocity u is equal to 0. Same concept. So this will give you 0. In this case, they give us the, okay, we have to find height. All right, height is equal to half 1 over 2 times g. The value of G is 10 times T squared. T squared is 0.15 all squared. All right, so get your calculator and punch this correctly. 1 over 2, open a bracket, times 10, open a bracket, times 0.15 squared. All right, punch this correctly. If you punch this correctly, your answer here will be 0.11 approximately. 0.11 meters in two decimal places. So do we have 0.11 meters here? Yep, that is option D. Option D, 0.11 meters. That is the correct answer. Next up, question 45. 45 says an object is placed in front of two plane mirrors inclined at an angle of theta. If the total number of images formed is 7, find the value of theta. A, 30 degrees, B, 45 degrees, C, 51 degrees, D, 90 degrees. So how do we solve this question? So take note that for 45, the number of images formed, N, is given by 360 all over theta minus 1. Here's the formula for that, all right? And they said 7 images were formed. So N is equal to 7. So you have 7 is equal to 360 all over theta minus 1. Move minus 1 over here, it becomes 7 plus 1, and that gives you 8. So you have that 8 is equal to 360 all over theta. That's the angle. From here, this becomes all over 1. So you have 8 times theta gives you 8 times the angle there, theta. It's equal to 360 times 1 gives you 360. To get the angle there, theta, divide here by 8. Divide here by 8. This cancels this. So theta, it's equal to 360 divided by 8. You have 45. Of course, angle in degrees. So that means they must be placed at 45 degrees. So do we have a 45 degrees there? Yep, that's option B, 45 degrees. So the value of theta here, that's the angle that it has to be placed for you to have 7 images, is 45 degrees. Okay, 46. Question 46 says efficiency of a transformer is equal to A, efficiency E is equal to secondary coil divided by primary coil times 100%. B, efficiency is equal to mechanical advantage all over velocity ratio times 100%. Now, this would have been true, but this is not for a transformer. C says efficiency is equal to number of turns in secondary coil divided by number of turns in the primary coil times 100%, which is still not it. Then D says efficiency is equal to power developed in the secondary coil divided by power developed in the primary coil. So you have this. Now this is true, but you're lacking the times 100%. So this, of course, times 100%. So for this question there, the correct option is D. All right, so D is the correct answer. Next up, question 47. What type of electromagnetic radiation can be used to take photographs in the haze? A, radio waves, B, infrared rays, C, visible light, D, gamma rays. For this question here, the correct answer is infrared. All right, infrared ray is the type of electromagnetic radiation that can be used to take photograph in the haze. Now, if you're wondering what a haze is simply an atmospheric condition where fine dry particles like dust or smoke or even other pollution reduces the visibility of the atmosphere. All right, hence you cannot see clearly because of perhaps dust or smoke or other pollutants. So the type of electromagnetic radiation that can still be used to take photographs in such an atmosphere is the infrared rays. All right, so take note of this. Next up, question number 48. 48 says the diagram below shows a closed square box of side 0.5 meters in a uniform electric field E in the direction shown by the arrows. So you can see the direction this way here, moving from left to right. What is the flux, that's electric flux of the box? Okay, so before we look at the options, you want to note that electric flux is actually this, and the unit is voltmeter. So voltmeter, that's voltmeter. The alternative unit is Newton meter squared per coulomb. That's Newton meter squared per coulomb. All right, so these units are not correct. That is if they're asking for the electric flux, right? So you have this either voltmeter or Newton meter squared per coulomb. Right, you have your options 0.00, B 0.2, C 0.5, D 2.0. Now, how do we solve this question? You want to note that for electric flux, the formula there is that you have this is the unit, or this is the symbol. This is equal to phi is equal to E A cos theta. Right, this is phi. Phi is pronounced or is spelled PHI. That's phi. So EA cos theta, what do you have there? This is equal to, what's the value of E there? The value of E, let's see. Oh, they said electric field, just E. All right, so leave this as E. Then you have A. For A is simply area. And if they give you the side as 0.5, and they said is a square box. So for a square box of size 0.5, the area becomes 0.5 times 0.5, which is 0.5 squared. Also, you now have cosine of theta. What's the angle there? Now, if you look at this, all right, if the field is this way, now when you have this moving in this way here, this way, you want to see that this is actually perpendicular, all right, to this. So the angle there is 90 degrees because the field is moving perpendicular to your vertical line. So it becomes cos, the theta becomes 90. All right. So let me explain this again. First things first, you have that phi is equal to electric field times area, then cosine of the angle with which the electric field is moving. This is equal to, the value of E is not given. We'll take it as E. Again, A is area. They said one of the side is 0.5 and it's a square side. So area becomes this one side 0.5 times the other side again 0.5, which gives you 0.5 times 0.5, that's 0.5 squared. Then cosine of the angle. What's the angle there? The angle, looking at this, all right, if I place my vertical line, this field is flowing this way, which is 90 degrees. So cos 90. So you have this as 90. This is equal to E into 0.5 squared. If you do 0.5 squared, you have your answer as 0.25. So 0.25 into cosine of 90 gives you 0. So that gives you 0. All right. And if you multiply this, you have that phi, which is electric flux, is equal to this times 0 gives you 0. So the answer there is 0. Right. Now you might want to say 0E, but 0 is 0. So your answer there is 0. So let's see which option there is 0. So for 48, the correct option here is A, 0.00. Right? So yeah, that's your answer. 49. If a normal sighted person loses the sight of one eye, he cannot A. Judge the distance of an object. B. See clearly a near object. C. B. See clearly a near object. C. Decode the shape of an object. D. He cannot see with it. All right. Now, if a normal sighted person loses the sight of one eye, then what happens? It's very simple and very clear. The fact now is that he cannot even see with it. Talk more of judging the distance or seeing clearly or decoding the shape. He cannot even see with that eye because you've lost sight of that eye. All right. So, of course, the answer there, the correct option is he cannot see with it. All right. If you say he cannot judge the distance of an object, that means probably he could see, but not very well. That means he cannot judge distance. If you say he cannot see clearly a near object, that means he can probably see, but not very well. If you say decode the shape of an object, what you're trying to say is that probably he can see, but then he cannot see clearly to either decode the shape of an object. But the thing is this: they said if the person loses the sight of one eye, If you lose the sight of one eye, you cannot even see with it at all. So the correct answer there is D. He cannot see with it. That's the most correct option. All right, our final question, 50. 50 says, which of the following is a vector quantity? A, temperature gradient. B, mass. C, work. D, time. So which of these is a vector quantity? For this question here, the correct answer is A. A is temperature gradient. Now, if temperature gradient is a vector quantity, it means it must have magnitude or numerical value and it must have direction. So what is the direction of temperature gradient? You want to take note that a temperature gradient points in the direction of the greatest temperature increase. So that's your direction. So for temperature gradient, it has a value, and for the direction, it will always point in the direction of the greatest temperature increase. So that's why temperature gradient is a vector quantity. Mass, work, and time are all scalar quantity. All right, guys. So this is the end to the 2021 JAMB Physics examination questions. We'll also provide the past question and solution for other year in our subsequent videos. Okay, guys. So please take note that we have a JAMB WhatsApp group for 2026 JAMB Bites. All right. So if you're writing JAMB for 2026, we have a JAMB WhatsApp group where we do daily revisions on physics, chemistry, mathematics, and biology. So if you're a science student and you want to join our JAMB WhatsApp group, I'll leave a link to the JAMB WhatsApp group in the video description. All right. You can also join our JAMB channel membership to get access to exclusive content for JAMB Bites, or you can get the full JAMB course on our website. Simply visit www.jonahimmanuel.com/courses and you see the JAMB/WAEC classes. All right. Okay, guys. So if you enjoyed this video, don't forget to hit the like button. All right. Like this video. Also leave a comment. All right. For the comment, I gave you a task, question number 11. Solve it. Leave your answer in the comment section, and I'll tell you if you're correct or not. Don't forget to also subscribe. If it's your first time here or you're yet to subscribe, please do what to subscribe. Hit the bell icon and select all so that you get notified whenever we upload a new content. Then finally, ensure to share this video to your friends and their colleagues so that they can also learn. Thank you and see you in our next class.